Okay. So good afternoon. Today we're going to talk about AppEngine, and we're going to try to make it implode. So I hope nobody will be hurt during this talk. So I'm Ludovic Champenois. I'm the lead tech lead and manager for the AppEngine runtimes and SDK. So it covers both Java and Python on the runtime side and the developer SDK as well. So this is the overview of what we will address today. So we'll do a quick intro on what is Google at the scale. And we'll talk a little bit about Google Compute Engine, because this is a new offering from Google, and we'll see how we can make advantage of it. Then we'll talk about the traditional App Engine, quickly go through services and APIs, and really talk about what's new in AppEngine regarding modules and what we call VM-based backends. We might end the talk if we have enough time to talk about lock-ins with AppEngine APIs. So this is Google Data Center. Basically, what is Google Cloud Platform offering is basically offering you our internal data centers we use every day for our business to run your application. Okay, so basically, we really want you to use one of those racks, and it's highly secure. We have guards looking at your processing. So this is what it is about. Okay, we have created data centers for our own internal usage, and we just want to use the same technology we are using every day. Now, whether you run one instance for free, you want to try, there is no issue with that. Or if you want 5,000, 10,000, it doesn't matter, instances or machines. So at Google, we do currently three big things. The first one that you might really know well about is software as a service. I guess you are mostly, all of you are using or have seen Google Docs or Google Mail or Google Calendar. Those things, they are software, they are running. Okay, so you go to a page, you use the software. The Google Cloud Platform is more focused on the two remaining parts of the cloud. The first one is platform as a service for AppEngine. AppEngine was one of the first provider in this area. We launched it in 2008. And recently, we introduced the infrastructure as Google Compute Engine. So we're going to talk about those two pieces on the left side. So Google Compute Engine, again, as I said, we want your application to run you want your application to run here, exactly on this rack, on this server. So we could talk about it, but let's do a demo. Okay? I will switch to a real Cloud Console project. So I have many projects. One of them is Cloud Roadshow demo. Here, and I will go to the Compute Engine tab. Okay, so here you see I have one instance that I've created last week. So I will create a Compute Engine instance that we can call Devox. Easy. We will we'll pick it in Europe. This is a machine type, one core, one CPU, 4 gigs of memory. We could pick 8 CPUs, 30 gigs of memory, but let's pick the default one. And the image will pick Debian, okay, but we have a bunch of them here. And you can add your own. So let's go down. One thing I wanted to let's create it. Okay. So basically here I'm using a web console to create a new machine that will run in the Google Compute Engine data centers. Okay. So very easy. Now it's booting, so now it's up and running. So now I have a machine. Okay. So if I click on it, I can look at the machine. I have an internal IP address here. I have external one as well. And I can go here, and let's say I want to connect via SSH to this machine. Here I can copy-paste this command. You know, I'm not good at typing in terminal. And I will paste, and let's see if the machine is up. Yes. Yeah, so the machine is up. Uptime, sudo apt-get, whatever. Install Apache 2. Bang. Okay, so this is installing. So this is creating one VM from a web UI and accessing it with traditional mechanism. So moving back to the demo. And it took less than a minute maybe to boot this VM, and I mean to create it and to have it online and accessible. Okay. Well, now we are Google. Okay, one is not enough. 100 is maybe for simple demos, but let's try to see if we can do. I don't know, 100. Yeah. So here, this is an AppEngine application. Okay, running in Hotspot, that will launch, let's pick more than 100. That is using Compute Engine APIs, very simple APIs to use. I mean, REST-based, and you have client in Python or Java, very simple. And we are just spawning 128 VMs. So exactly the same way that I've done before. So this is the status of the VM. They are booting. They start responding to network calls, so they are up and running. So we have 4, 5 green, so they are fully functional. I could SSH to any of them. So meanwhile, while it's doing that, I will look at the Cloud Console project for it, and you will see those VMs, same way as the one that we have created with Devox. We'll see them booting, nicely. So quick start 1, 10, 100, etc., etc. Okay. So I could SSH to any of them. Okay. I could apt-get, install whatever I want, and then start doing a master VM, sending traffic, compute activities, Hadoop, running on those VM very easily. So let's go back to this screen. It's almost there. Okay, and it's only 1 minute and 20 seconds. So I guess in less than 2 minutes, I was able to boot, 1 minute 25. We could boot 128 VMs. Okay, let's shut them down because I don't want to pay that much. But now we are killing them, and if we go back to the console, you will see them slowly being shut down and then killed and completely removed from the system. Okay, so in 18 seconds, we did all the shutdowns. So this is the power of Compute Engine today. Okay, this is what you can do. Create programmatically VMs, allocate jobs to them, and use them. Okay. So highly flexible. All the disk in the disk we use for those machines are fully encrypted. They are running obviously inside the Google network. So which means that if you put some processing accessing to data store or accessing to Google Calendar APIs, you will not leave the Google network, so that all those internal communication will be extremely, extremely fast. Flexible billing is very important. So what we charge for VMs is per the minute after 10 minutes. So if your compute power processing time takes 15 minutes, you will only pay 15 minutes as opposed to 1 hour. So if you think about it, you could even buy 5 VMs for the price of an hour in one single VM in another IaaS provider. Okay, so it's pretty good in terms of cost. So you can obviously set up, describe which disk you want. Scratch disk or persistent disk. You can create a disk with one VM and then shut it down, and we replicate it everywhere that in all the data centers, all the zones we have, and you can open it again from a different VM. Obviously, we say green computing because it's completely powered by the power grid that Google is managing or even implementing. So sometimes we are buying electricity plants just to power those data centers, and they are extremely energy efficient. So up to terabytes of persistent disk. We have up to now 64 instance types, and it's growing. We keep adding them maybe every month or 2 months. Networking can be fully configured. You can open firewall rules to listen to port 8080 if you want, or to communicate privately between those VMs. So you can decide if those VMs are public to the internet or only have access from other VMs or processes running in the cloud platform. Whenever you create a VM, you can also allocate some metadata for it. Okay, that metadata can be accessed using a standard HTTP port running inside the VM. So let's say you want to get a key value pair. You want to get it. Your creation script has set it up. Then you can pass information between the creator and the VM itself. We have just recently added a load balancer layer where you can talk to one instance that will route the traffic to many VMs. Monitoring, you can snapshot the disk, shut them down, and restart them later if you want. Okay, so all this is nothing new. If you have done virtualization before, it's nothing new, but it's just running inside the Google data centers and Google networks. Okay, so here they did 500. Well, no, 100 was 1 minute 06 for this slide. Okay, so this is we are here, but to talk about App Engine. But I wanted to do a quick introduction of the other offering, which is Compute Engine, because you will see that they will be integrated more and more going forward. So App Engine, this is a traditional platform as a service offering from Google. It was out a long time ago. We support many runtimes, so it's fully managed, easy to develop, easy to deploy. You don't know if you have one instance running, 500, 10,000, you don't care. You cannot really tweak the load balancer settings because we do that for you. You don't care about zones. You don't know, well, the only thing you care about is whether you're in Europe, in Europe or in the US, but this is the only thing you can control. So basically we want you to forget about all those data centers, VMs, processes, memory, because we want to handle this management for you. And obviously we scale almost to infinity. And the typical customers for App Engine, they don't really know in advance the traffic they will have. Okay, some have very static traffic, but most of them, either it's a peak in 1 hour per day or 2 days per year. It doesn't matter. Okay, and the only thing they want is when you have customers using your website, they want to handle the load, okay? And we do that for them. So, and we charge them only for what they use. So if one day they have 0 customers, they will pay 0. Maybe a little bit for storage, even if it's not used, but nothing for traffic, nothing for bandwidth and etc. So you just pay what you use, and you don't care about who is doing the backups, who is doing the failover, who is doing the replication across regions, because we, Google engineers, I mean, we have the Google engineers handling the Google software inside Google are also handling those applications. In fact, for them, they don't know if the process running on a data center rack is a Google search or a BigQuery activity or your own business logic running in this rack. Okay, so if there is a failure, they will handle it in almost no time. So we passed 7.5 billion daily hits on web applications hosted in AppEngine, so it's pretty big. We have more than 1 million applications. Last year, exactly at Google I/O last year, we were doing 2 trillion data store operations per month. And this year we are doing 4.5. So this is, from 2 to 4.5, this is the growth rate we are doing every year. So in terms of data store operation, in terms of number of customers, traffic, revenue, we are not doubling the engineering team, but not far, okay? So we are, this is not imploding, but exploding business. So we try to do 1 release a month, and now maybe once every 3 weeks, with 4 different languages. So at Google I/O this year, in May, we announced PHP. Up to 4 or 5 weeks ago, it was still a private early access language, but now it's open to everybody. So if you want to run your WordPress or Drupal PHP application in AppEngine, you can. And we will scale it to whatever you need for your customers. Go was released in late 2011, so it's still it's not GA yet, so it's still not as supported as Java and Python, which are fully supported by Google. So, but Go will be soon GA. This is what we are working on now. So yeah, the rate here could be whatever the revenue, number of customers, or daily hits on our application running AppEngine. So it's pretty massive. So we can switch to a demo quickly. And for that, I'm using my preferred development environment, which is NetBeans, but I could use Eclipse or IntelliJ. Usually I have the 3 of them open on my Mac, but today I've decided to pick NetBeans. So it's a Java web application, and it's a Maven-based application. So it's on GitHub. You git clone it, you do MVN install, you have the web application. So an AppEngine application has web.xml, but it has also an extra file called AppEngine web.xml. So we're going to look at it. And then the POM file has a few dependencies, some testing APIs, and then we have the AppEngine Maven plugin that allows you to do many things. For example, run locally your web app on your desktop or laptop, update to push your application once it's debugged locally and developed locally to push it to the cloud, and then a few other random command line stuff that you can all do using MVN, AppEngine, and then the name of the command. Okay, so very nicely integrated with Maven. We are also now currently working on a Gradle plugin. The reason why we are working on the Gradle plugin is the Android team decided to move to the Gradle build system for building Android apps, and I think it makes sense to have an end-to-end story for a common build system if you are doing Android apps with AppEngine backends, which many customers are doing. So let's, quickly run this application. It's really a stupid application, okay? We are not here to learn how to write web applications. We are here to see what is there in AppEngine. So, not there. Okay, so let's see what happened. Maybe I was booting it before. What did I do? It's already running? Ah. Well, if it's running, then it should tell me, no? The port is used. Okay, so let's kill the port. Yes. Oh, exit. I'm still in my VM, sorry. Let's kill it. I ran it before the demo, and obviously it didn't work. So go back here. So going here, again. Okay, nothing fancy. And here I have just a servlet that I want to use to do some testing. Okay, so I'm just printing, hello, this is a test servlet. Okay, so let's now deploy this application. So, I can fully debug it with whatever ID I want. I can add business logic, and once I'm happy, I'm doing AppEngine update. So I'm pushing this local web app here on my laptop. I'm pushing it to the web. So before pushing it, let's look at the application web.xml. I have two critical things. I have an application name. I'm using VM runtime demo. And I have an application version. Okay, so I call it version devox 2013 non-VM. I don't know why. Okay, so let's deploy it. Okay, and while it's being deployed, we are now moving to the AppEngine dashboard console for this web application. So the application name is called VM runtime demo. So this is what you have seen in application web.xml. And let's look at the versions here. So every AppEngine application is fully versioned. And we keep alive all the versions you have been deployed. You have deployed. So here, I have deployed 3 of them. The first version name, so this is a version name. Okay, guestbook. Let me make it bigger. The first one is guestbook, and this is a default version. Okay, so if I will open this in a new link. Okay, so let's remove the local one. Here, I'm running on AppSpot, my application name, so VM runtime demo, and my version name. Okay, so if I put my version name, it's the same as put no version name at all. So this is exactly the same app, the same processing, serving this request. Okay, and we've just deployed these versions. Let's look at it. So to see it's different, I just changed the CSS color, okay, so that we can see that it's a different application, but it's the same top-level domain name. And here, you have to specify exactly the version name to route traffic to it, okay? So very simple. And the reason why we have that is, first of all, we want you to try new version of your software without having all your customers using it. So it's a good practice anyway to do A/B testing. And you can do that very simply by using the traffic splitting mechanism in the UI to say, I would love to route 20% of my traffic to this non-VM version that I've just deployed. Okay, so you click OK, and after a while, if I click 10 times on this URL, okay, I might see only 2 times the red appearing. Trust me. Okay, maybe not on my demo, but with multiple IPs. Okay, so even using this URL, you will sometimes use 20% of traffic running on the new version. Okay, so let's remove this rule because I really want to know which one I'm talking to. Let's delete that. Okay, so it's back. Okay, let's quickly move to the dashboard. You can see that I've done some traffic before going in this room, but the last 30 days, you can see when I've been in conferences there a few days ago. And you can see the billing dashboard. So my application is free, so I did not enter my credit card. So I have some quota that I can use. So I have, for example, 28 hours per day of instance CPU time, which means that I could use one instance plus a little bit of more than one per day. I can store 1 gigabyte of log file. I can access the data store up to 1 gigabyte, etc., etc. So this is my dashboard to see how much I need to pay or not. I can look at the logs. So here, if I click on the log, I can pick which version I'm looking at, and I can filter by error or whatever. I can also export the log files to BigQuery and do big data analysis on them if you want, but we are not doing that today. Okay, so very simple to administer, and from the development side, it's very also simple to use. So I will just modify my really, really stupid servlet, okay, that I'm using in test, because I will modify it to do something like oops, typo. I'm just adding, I'm accessing an object called dimension from the AWT library. Okay, so I will try to, let's say redeploy. Okay, so I will update the cloud. I could also test it locally, but let's do it live to see the behavior of this modified code here. So moving back to the UI, going back to versions. I think it's still deploying, but let's try. So I'm clicking on this guy. Should be up in no time. And the URL will be test. I have an error. Okay, doesn't work anymore. The reason I have an error is, maybe it can be seen in the log file, is I'm using a class which is not allowed to run in the AppEngine environment. And the reason why we have those restrictions is your application, so your business code is running in the same machine as possibly another process running by Google. Okay, so your web application can run same data center or same rack as internal traffic. So we don't want you to look at what's going on in our data centers, obviously. And the JVM, the Java platform is not secure enough for to do that. So we have many protections in place, but we want to make sure that only your business logic will run without any side effects. So for example, AWT is using plenty of native code. And when you talk to the Google security team, they know how to break a JVM, even with a security manager installed, if by using buffer overflow or whatever, by using this AWT library. That's why it's not allowed to run in AppEngine. Another thing which is not allowed, for example, is java.io.file. I mean, creating a file in the cloud is, I mean, using the java.io.file is, I mean, useless because, you know, where is your file on which VM, you know, doesn't make sense. I mean, so the java.io.file is not a cloud-ready API. So there are a few restrictions like that, and it did not prevent us to grow as much as we are growing. So customers, they realize that they have some restriction, but this is the cost to pay, the price to pay if you want to be highly scalable in the cloud. So let's move back to the presentation. So I've just, you know, deployed a broken application because some URLs do not work anymore. So high-level view of how we implemented this entire runtime. The request that your customers is emitting is arriving what we call front end, and these are Google-wide front ends. So they are all over the world. So if your customers are in China, we have front ends very close to China, in Africa, in Asia, in South America, etc. So this is basically the same front end that are serving Google.com. You know, whenever you search something, it's as fast as it can be. Then the traffic starts entering the Google network. And there it's completely handled by Google. So we have internal cables, networks, etc., to route the traffic to the right data center on the correct track. And all this magic is done by same layer as internal software we are using at Google, and it what we call the app server tier, which is in charge of running either a Python runtime or a Java runtime or a Go runtime or a PHP runtime. And you, as a customer, you can put some business logic here, accessing services that we offer to you that are up and running. So, for example, a data store service, a highly scalable NoSQL database, very simple to use in your application. You could, if you want, also use MySQL, because we also have MySQL hosted in our data centers. Closely related to data store, there is a memcache layer where you can cache some data store objects that you have back from the database to make sure that they can be shared eventually between multiple requests. So, you know, you try AppEngine and quickly you always add the memcache layer because it will reduce the cost of your application dramatically. Okay. And then we have other services. For example, one is the user. You can authenticate your users. Your users if they have a Google account, so you know who is using your business logic. URL fetch based on the same web crawler that Google is good at using and developing. You can fetch data from other websites using the URL fetch APIs. TaskQueues if you want to do batch processing, so we'll talk about that a bit later. One thing I did not talk about is static files. You have seen the CSS that have changed. The static CSS is not served by the Java runtime. Okay, it is served by the content delivery network from Google. So all HTML, JavaScript, CSS files, images will be served by, the best network on Earth, basically. So these are the list of APIs and services we are providing. So all the services are up and running in the context of your application. Okay, so you don't need to install Cloud SQL, you don't need to install data store or a memcache, it's there, okay, no problem. User identity, you just use a very simple API to get the current user, and either it's null and nobody's registered to your site, or it will give you the real user ID with a Gmail address. So we have very, very advanced APIs for searching, for example, XMPP channel if you want to do chat with customers for XMPP, mail APIs if you want your application to send emails or even receive email and execute some processing, you can do that as well. So you can really create automates with mail communication. So I briefly talk about TaskQueues. Typically, we have up to now, we had two types of machines. We had front-end machines where your request could not run more than 60 seconds, which is infinity. You know, if your website does not reply in less than 60 seconds, I mean, you will not have customers most of the time. Okay, so this is why we have this limit, and it's a very small machine, front-end instance class. It's, you know, F4 has only 500 megs of memory and 2.4 gigahertz. So this is the biggest front-end we give you. Okay, but you can boot 10,000 of them. Okay, so this is where you will put your real-time logic. Okay, very simple request response model. You cannot spawn a thread because anyway it will be killed after 60 seconds. So up to now we had a notion of backends where you don't have a limit for processing, and this is where you execute batch processing. You know, you push jobs on TaskQueues, and the jobs are executed when we have the capacity, or so you're not really tied to real-time processing there. So people are using, for example, MapReduce processing. We offer a library for map reducing with AppEngine, image processing, whatever, long-running batch. TaskQueue-oriented processing where you can save the state of your task and continue the work, maybe possibly in different data centers. You don't see it. So this was up to this summer. So this summer we introduced, we try to merge the two notions of front-end and back-ends because they are more or less the same, but they have different characteristics. The big bummer for our old front-ends is you could not create versions for them. Okay, so if you had mybackend.myapp@spot.com, you could not create version 1, 2, or 3 of your backend. Okay, so what we have done is we removed the notion of front-end backends, and now everything is versionable. Okay, so basically an application here, my application, is composed of n modules, and each module has many versions, possibly, and those versions are independent. So you could have my front end having 10 versions from 1 to 10, and my backend having only 2 versions, V1, V2. Okay, and you can update independently of the other those modules if you want as well. And then you have the instances, so between 0 and n, or for each module. So at the bottom of the slide, you have the URL to access your module. It's mymodule.myapp.appspot.com. So that would go to the default version of the module. So now let's say you want to access to version 2 of your backend called mymodule. You would prepend in the URL mymodule, you will prepend version 2.mymodule.myapp.appspot.com. Okay? So you have a notion of default value, default version, but you can override it in the URL. So very simple, easy to understand. So if you are a Java developer, you will understand that we have reused the enterprise archive format to help you doing development. So if you understand the EAR file using WTP or NetBeans or even Maven EAR plugin, you will construct your module as one single web application, and then your application will be an EAR file containing many, many modules. Okay? But as opposed to traditional EAR files running on JBoss or Glassfish or WebLogic, each module will run in an independent JVM process. Okay, so it's completely different than the traditional Java EE model. But all the tooling is done using EAR files. So as I said, I mean, now you can allocate, you can define properties, scaling properties on your modules. So you could say, hey, automatic scaling, and this is the AppEngine classic model. AppEngine takes care of the loading, up and down. Or you could say, let me boot 10 backends because I know I will need 10 backends. Okay, so at deployment time or update time, we boot 10 of them. And they are up and running forever. Okay, no big deal. I mean, as long as you have a credit card associated with the project, we'll charge by the hour, those whether or not you have traffic. And then basic scaling, scaling from 0 to 10 because you don't want to be more than 10. Okay, so you just define the maximum number of instances you want. Okay. So very easy to set up, and all those settings are done in the application-web.xml file. So nothing new to do there. So in fact, if I go to the NetBeans side here, go back to this guy, I just define the name of the module here. Okay, so it's a third element that was not there before, but if it's not there, by default, the name of the module will be default. Okay. So far, so good. I can now cut my large application into smaller units, so it's good. I mean, for modularity. Each unit will run on its own JVM, so you can scale, I mean, you can scale with many JVMs, but also you can design your large application in a much more modular manner now. And all those modules, obviously, they are part of the same application, which means that they share the same memcache, same data store, same user authentication, etc., etc. Okay. So now, you would try to say, oh, I have AppEngine and I have Compute Engine. It would be nice if I could combine the quality of both sides in the same single programming model. So this is what we are doing with what we call now VM-based, VM-managed backends. And it's really changing how, I mean, you as a customer of AppEngine will do things in the future. So basically, a VM-based backend is just an AppEngine module, or N of them, in your AppEngine application. But instead of running in the restricted JVM environment that we do for the traditional AppEngine, we will run this web application inside a Compute Engine VM. Okay? So by doing that, we allow you to do whatever you want on this VM. Okay? Because you will not be able to escape the VM layer, but you can escape the layer of the JVM. So you can create a java.io file if you want. You can system exec etc shutdown if you want. No problem, because you will shut down you, not the Google machine running your instance. Okay? So, which means that we don't have anymore this whitelist, blacklist model in AppEngine, because you can run everything that you can run outside, I mean, without a security manager and restriction in the JVM. Then you can also decide which type of VM you want. You have seen front ends, 512 megs of memory. It's, even my phone has more. Okay, you can now use a VM with 16 cores or more. I mean, have a persistent disk of 10 terabytes. Run some scripts, maybe possibly a apt-get native shared library written in C++ and do GNI call from your web application, you can do that. Okay, so basically you have the full power of Compute Engine, but you keep the simplicity of the AppEngine model. Okay, so let's try to do a demo of that. Hopefully it will work. So in order to, so in this web application, I have only one module, okay, which is the web app, okay, but you see the point. So I will transform this one module from a traditional module to a VM module. So you do that by just uncommenting that or typing it if you're good at typing. But the key element here is VM true, okay, simple. Then you need to say which type of scaling you want. Okay, so here I say manual scaling, and please boot one VM for me if it's not booted. Okay, so we do not have yet automatic scaling for VM runtime, VM-based backends. We have only manual or semi-automatic. Okay, but we will not scale to infinity traffic for VM-based backends yet. Okay, it's in the work, but we don't want to do that yet. Then you could, so this is just an example, but you could say, while you are provisioning my VM, let's, run this, okay? Run apt-get install Apache 2 if you want. Okay, so you can have n settings. So let me save this. And I will now just say, hey, I want to deploy it to a VM. So I don't want to override my previous version. I want to create a new version, and this new version will run in a VM, and the old one will keep running on the traditional backend, front end. So let's do the same, update. So remember, I have added this guy here. So we'll see how it behaves now in this VM-based version. So it's deploying here, checking again. So here, it takes anytime between 10 seconds to sometimes 40 seconds. The first time you deploy to a VM, we need to create it. We need to boot it. We need to install OpenJDK. We need to install our AppEngine agent, who is talking back to Google servers. We need to provision your web application. So we need to do a few things. So we are working a lot trying to speed up this processing, but it's all obviously slower than booting a pure JVM inside a Google data center that we manage automatically. But anyway, in 47 seconds, I was able to do all this. So let's go back to this guy, and I will go to the versions tab. And here I have my VM. So if you, I don't know if you can read, but the default version is a Java 7 type runtime ID. The non-VM is a Java 7, and this guy now is a VM. Type of runtime. So I click on it to see if it is working. Wow, thank you. And now let's see, I don't know, if the test URL is working. It did not work. It did not work. Okay, so maybe it's still uploading. Okay, let's try to do something while I'm recovering from that. VM2. Okay, I will create a new one. So while it's deploying a new one, so now we are creating a fully from scratch a VM. Here, let's make it bigger. I'm just listing the system properties, okay, of the system. So you can really see that we are using OpenJDK. It is installed there, so it's a real VM. We have nothing to hide here, okay? The vendor is Oracle. As you see here, we are using something called JD. Oh, surprise. And it's a Linux system, etc., etc. Okay, and it's in fact, if you look at the JD version, this is the one that was built, released 2 weeks ago. So it's already supporting servlets 3.1 and all those, new things. We don't expose them yet, but the runtime already is using JD 9.1 release candidate 0. Okay, maybe they did release candidate 1 this week. Okay, so now let's see if the new VM has been deployed. So let's do a reload. Okay, it is there. VM 222. So let's see if this one. Okay, it's not ready yet. So while we are waiting for it to be ready, I will move to the Cloud Console view of this AppEngine project. So we are still trying to merge our two consoles. I mean, we have one for Compute Engine, one for AppEngine. So we are still trying to merge two big products together. So here it's a different UI than what you have seen before. But you see the first VM and then the second VM that I've created, VM 222 here. Okay, so it's running on the US zone. So let's see if I can. Not this one. So where was it? This guy. Still not up and running. Okay, too bad. My demo is not working yet. No, it was not this one? Okay, so let's click again here. Thank you. So now, let's see if it's really what I've... No? What happened? I don't know. Okay? Because here... Oh no, maybe I did not print it. But anyway... oh yeah, I did system out. Sorry, I did not use a println. Okay. But anyway, it did not explode. Okay? And which means that it's working. Basically, okay? So, yeah, I should have S out is not good.
Is this the way you're doing testing at Google?
Yes.
It doesn't explode this one?
Yeah, because if I go back to the non-VM version, the same URL, okay, will not work. Okay? So let's quickly move to the last topic of what we want to address today. So, I was using AWT dimension just as an example. In fact, if you look at the sample itself, I have a second servlet here called PDF, which is using this PDF generator library that you could not use in traditional AppEngine. Why? Because it's using also a lot of native code. Okay. Now you can use. In fact, let's look at it. But you can use PDF. So which one is it? No. Yeah. No. Oh, it's complicated. Go back to version, click there. PDF. Sorry. Okay, doesn't matter, but it's working. I have a few more minutes to address what I want to address now. So you can use anything you want. So, quick slide on locking. So you say, I'm using AppEngine, but yes, I can use servlets, I can use JPA, but if I want to use your cloud data store NoSQL database, I cannot move to another one. Or I cannot run my application in my garage. Why? Because we don't sell data centers for you to install in your garage. So basically, you say, oh, once I start using App Engine, I'm locked. Okay. So, well, yes, it's usually difficult to migrate from one stack to another one, but we're trying to help there. Okay. Basically, if you are using App Engine, you realize the benefit of having nothing to do to manage your application and access to a massively scalable NoSQL data store or user authentication and failover, etc., etc. But we want to move a little bit away from that. So we have been working on something called AppEngine TCK. And why we have been doing that? Because there is a partner, and the partner is Red Hat, so next to the Google booth. And Red Hat wanted to implement the App Engine APIs on top of their Java EE stack. So JBoss application server, renamed Wildfly, whatever. But what is funny is, the leader for the Java EE platform, because Red Hat is really the leader in terms of contribution to the Java EE APIs, is also now working on a layer above those Java EE specifications to implement the Google App Engine APIs. So I'm very happy and proud about that because maybe they realize, good cloud APIs are more App Engine centric than Java EE centric. In the Java EE land, you can do java.io.file. Well, what does that mean? Nothing. Okay. You can use Corba. Who cares about Corba? Nobody. So anyway, the project they're working on is called CapeDwarf. Okay, so it's an extension of their JBoss application server, and we said, fine, we want you to implement our APIs, but we want to make sure that your implementation is correct. So we have been working with them on a technology compatibility kit, TCK, to prove that our implementation and their implementation is working the same. So basically, this TCK is a combination of two organizations, Red Hat and Google. So all our QA department is moving more and more tests that we have done internally over the last 5 years at Google testing App Engine. We are moving them under Apache license on a GitHub project. And the JBoss guys are also adding a lot of tests there to see if their implementation is running. Okay. So it's Maven based. They are very good at doing testing with Maven at Red Hat. And when you run the test, you can also get API code coverage. So these are the list of all the App Engine APIs. And let's say if search, I click on search, this API void delete on the App Engine API has been tested once here. And if you click on the link, you will go to the unit test using those API. So you could use this with many ways. Okay, learning how to use Google App Engine APIs. Okay, or if you find a bug as an App Engine customer, you find a bug in App Engine, you say, this API, the combination of those three calls, doesn't work. Well, instead of filing a bug and calling support and whatever, you could check in the unit test in this App Engine TCK, and because we are running it every day or every night, okay, it will maybe fail in App Engine and it will not fail in Red Hat implementation. Well, we will see it's failing, okay, and we don't like failing tests at Google, okay, so we'll do something about it. So it's much easier for us and for you to communicate and work with us on providing your unit test so that we can fix those bugs. Okay. So the last thing I wanted to see is, so we are working on them, and in fact, people from Fairly are helping us because we want to involve the open source community here. So I've created an AppEngine application that will be in charge. So currently it's a toy implementation, but we have one guy from Surly, so working with us now, that will do a much better job of doing the report. So this is the report that the Red Hat guys did a month ago. And as you can see, our implementation, our SDK, is failing a little bit more than their implementation. Okay, 3.3%, and we are at 5%. And when I show that to my engineers, they're not happy, So they're gonna fix that because it's a race, okay? So we keep adding tests, or you can add tests, and now the race is how much compliant we are in our implementation. Okay, so still, more or less, brand new projects. So a lot of people involved inside Google moving tests outside, and it's very good to be able to run AppEngine apps in your garage if you want. You can. Don't use our implementation. Use JBoss implementation. So with that, I think I'm done. Maybe I'm lost. I lost the presentation here. Okay, let's scroll down. So just to conclude, applications are moving to the cloud. If you are not there yet, you should look at it because this is coming. Try AppEngine, you will not be locked in, and you will be able to have the entire power of Compute Engine if you want soon. So the VM-based backend is still in early access mode. We are still trying to improve boot time and capabilities there, but this is definitely the direction where we want to go. Getting the best of both worlds. AppEngine PaaS model with Compute Engine power. So thank you. I don't think we have time for questions, but I'm sure I'll be around to answer your questions if you want. Thank you.